Hi everyone, myself Bidyutlata Sahoo, working as an assistant professor in the Department of CSE, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. Today I am going to discuss about the navigation and motion planning in robotics on the course Applied Artificial Intelligence. These are the topics I will discuss. First, I will introduce about the navigation and motion planning. What are the key components of the robot navigation and different types of environment where the robot will navigate, and a little bit concept about the configuration space, as well as two different techniques for path planning. This is the topic learning outcome for this particular topic. After the completion of this topic, students can understand the navigation and motion planning algorithms for autonomous agents, including path finding, obstacle avoidance, and trajectory generation in dynamic environments. Okay, let me introduce what is the meaning of navigation and what is the meaning of motion planning. So navigation, it is the ability of the robot to determine its position and plan a path from starting point to the destination in each environment. That is what it is called as navigation. So navigation, we can say in the broader sense, it is called as the navigation, exploration, or else we can say the alternate name for the navigation, exploring the path starting from the start location to the destination irrespective of any environment. But motion planning or the path planning, it is nothing but the computational process which is done by the robot for determining a feasible path for a robot to move from one configuration to another configuration. In my previous videos already I have discussed what is the meaning of configuration space and what is the meaning of workspace. Workspace is the real space where the robot is present, whereas the configuration space is the virtual space or the virtual environment for the robot where it is located. And this workspace to virtual space, that mapping will be done so that the motion planning or the path can be planned by the robot from starting point to the destination. That is called as the motion planning. Now, these are the key components of the robot navigation. First one is the localization, then mapping, then path planning, and obstacle avoidance. So all these components we need to know so that the robot, then only we can understand how the robot plan its path and as well as it tries to explore the environment. The first one is the localization. So localization, as the name it implies, finding of its location. That is the meaning of localization. So localization is the process of determining robot's position as well as the orientation. That means called as the pose is a known or partially known environment. Anyways, I'll discuss about what is known environment and partially known environment. In my previous videos already I have discussed what is the meaning of known and unknown. Still, I will discuss in this video also. So localization means locating the current location of the robot, its position where the robot is present. That means whether the robot is present in a two-dimensional space or the robot is present, this is a 2D space if it is present in 2D plane, and if the robot is present in a 3D space, then Z-axis would be there, and its orientation. Orientation means the angular movement, the orientation angle. So angular movement, sometimes robot may take a angular movement also. That is called as the orientation. So based upon the space, whether it is a 2D space or it is a 3D space or the orientation, irrespective of any angle, that is called as localization. Basically, there are different types of localizations are there, like relative localization or absolute localization or probabilistic localization. Relative localization means what? If robot tries to find out its location with respect to the obstacle or with respect to the surrounding object, Okay, then that is called as the relative localization. There also some distance metrics are used to find out how much distance it is maintained from the obstacle. So for to find out all these things, it uses the internal sensors. Using that, it accepts the or receives the informations or the data from the environment and tries to find out the distance from the obstacle to its current position. And absolute localization is nothing but the exact location of the robot. So for that, especially it is used in the dynamic environment, means where the drone, it's all like if you consider the example of the drone, then drone works in the dynamic environment, so that depends upon the force from the air and the pressure of the environment. So all these things considering, the robot will move. So for absolute localization, that means in its surrounding what are the obstacles are there or nearby other robots are there. So for that, it uses the external references. And the probabilistic localization means it uses the filters to estimate position with uncertainty. So especially it is used in uncertain situations like search and rescue environment. This is the example for the localization. A robot equipped with the laser scanner uses known landmark in the room to determine that is at coordinate 3.2 and 5.1 facing 45 degree. That means it is a two-dimensional space and the robot is moving in an angular movement of 45 degree. That is called as the localization at a particular moment. Then the next component of the robot navigation is mapping. So once the robot's position is determined by the sensors data, then the environmental condition, the physical space should be configured with the configuration space. So that is called as mapping. That is called as mapping. So mapping is the process of building a map of the environment using the sensors data. That is what I told. Whatever the data are received or perceived by the sensors of the robot, that will be configured into the robot hardware component. Then only robot can plan a path, or else it can navigate or it can explore the environment. So all these sensors, like we know that different types of sensors are used in the robot, like lidar sensor or sonar sensor or temperature sensor or light sensor or camera sensor. So using those sensors, depending upon the environment, it receives the data and tries to convert or tries to map with the configuration space. So different types of maps are also used depending upon the situation, like the metric map, topological map, or semantic map. As the name it implies, it is called as the metric map. So that is why it is made up of like the grids, like in the form of rows and columns, where each cell, this is once the intersection between rows and column is called as a cell. So each cell represents the probability of occupancy, like 2D grid map. In my previous video already I discussed the each cell will be labeled as either it is free or it is occupied. If it is free, suppose this space is free and this space is free and this space is free. These are the free spaces. Then robot will senses what are the free spaces are available in the grid, and using that free space, it try to draw the path. That means it will first it will try to find out where is the free space is there, and based on that, it's not only the single path is there, the single free space, so many free spaces should be there in the 2D graph or 2D map. Then it has to find out which gives the shortest distance starting from the initial location to the destination location. So this is the way it can explore. So that is why the metric maps are used. Similarly, the topological maps are also used for the exploration or for the mapping. Here, the topological maps are nothing but the graphs representing the location as the node and paths as the edges. So, for location and the path, exact location of the robot, that is represented as the node, and the destination location also it is represented as the node, and the distance between the initial location to the destination, that can be denoted as the edges. So like this, the graph will be configured. So this type of graph representation is called as topological maps. And the third one is the semantic map. Semantic map means the map which is meaningful, which gives some information to the user with the help of some words. So that is why it is called as the semantic maps, which includes the object levels and conceptual information like the table or the door. So whatever the nodes and edges should be there, the edges should be named or labeled. Then the user can understand or the robot sensor can understand. So that is why it is called as semantic maps. So these are the different types of maps which are used for the mapping of the real space to the configuration space. Then the third component of the robot navigation is path planning. So after finding the location, then conversion from the real space to the configuration space or the virtual space inside the robot, then robot will plan based upon the configuration. So how the path will be planned. So path planning is finding a sequence of valid configurations. That means the position and the orientation that moves the robot from its current position to the target while avoiding the obstacles. So that means the robot has to plan in such a way that it should move in a free path without avoiding any or without colliding with any obstacles. So these are the steps are followed for path planning. The first one is the robot has to define the environment where it is present, that is called as the localization based upon the real-time data, and it also uses the map. And then it defines the robot configuration space. That means the workspace will be configured to configuration space. Then robot will use different types of search algorithms to find out the valid path, like A-star algorithm or RRT algorithm. Then after finding the path, all the paths may not be feasible or may not be efficient. It may take lots of time. So to reduce the time and cost, so it tries to optimize the path. So the optimizing means minimizing the distance, time, and energy. Then only we can say the robot is efficient and it saves time with less cost. So this is the way the path planning will be done by the robot. The next component of the robotic navigation is the obstacle avoidance. So obstacle avoidance means avoiding the obstacle. Very simple. So obstacle avoidance is the robot's real-time capability to detect and steer clear of unforeseen obstacles while following a planned path. That means while exploring a particular path in the real environment, it should not collide with any obstacle. So, but already I discussed in my previous video, whenever the robot receives or perceives all the data from the environment, like where the wall is, where the obstacle is, after receiving it, whenever it takes the decision, that means all the received data are in the form of raw data, then raw data will be converted into the structured format. While taking the decision by the robot, sometimes robot may take the decision reactively or deliberatively. So reactive means sometimes it takes reactive means immediate response using the sensor data without planning. Whatever the sensor receives the data, based on that it takes the action. You can take the example of the robotic vacuum cleaner. Whenever the robotic vacuum cleaner moves in our on the floor in our home, and if any obstacle comes in front of it, automatically it stops or automatically it moves left or right. That is called as the reactive decision. Whereas the deliberative means it receives the data from the environment, then it plans, then it takes the action. That is called as deliberative. So it uses the internal map and predictions. So deliberative means it when the same robotic vacuum cleaner, you can take the example. Some robotic vacuum cleaners are configured with the robotic decision activity. In that case, whenever any obstacle comes in front of the robot, it will stop at that situation and it has to find the complete path, any free possible path, and which is feasible. Then it takes the decision. That is what it is called as deliberative action. So one of the example here I have given, if a human suddenly walks in front of a delivery robot, it stops or reroutes around the person without recalculating the entire path. This is one of the example for the reactive, where the robot reacts immediately. Then let me discuss different types of environments in robotic navigation. As we have understood what is the meaning of navigation, that means the exploration of the path, and for the exploration it has to find the correct path starting from the initial position to the destination location without avoiding any obstacle. But all this exploration and navigation, finding the path, finding the feasible path for the robot, that depends upon what type of environment, where like in what situation or in which type of environment the robot is present. So robotic navigation depends heavily on the kind of environment the robot operates in. So there are the three different types of robotic environments are there for robotic navigation. One is the known or the mapped environment. Second one is the partially known environment, this partially known, and third one is unknown environment. Let me tell you about this known, unknown in general, then we'll go for the example also. Known environment or the mapped environment means if the robot is having the complete information about the environment, then that is called as known environment. Means the robot is present at our home. Robot knows where is the table, where is the bed, where is the sofa. It is fixed. The objects is not going to be changed very frequently. That is called as the known environment. Whereas the partially known environment, where the robot will have the incomplete information. 50% complete information, 50% incomplete information, half information would be there. In that case, robot may not take the correct decision at the right time. And third one is unknown environment. Unknown means robot has to explore its path at that particular moment of time, like rescue, search and rescue robots. Those robots, they will work in they will work in the uncertain environment. They have to explore the environment, and they have to they have to perform their task. So that type of environment is called as unknown environments. Now we'll discuss one by one the known environment, which is called as the mapped environment. An environment where the robot has the complete prior knowledge of the layout, including the position of the wall, obstacles, landmarks, and possibly the dynamic elements. Means small changes in the element or the walls, especially it is used in the hospital, the robots which are used in the manufacturing unit or in the hospitals, where all the objects are fixed and very frequently objects are not going to be changed. There, this robots are that is called as the known environment. So, an automated guided vehicle (AGV) is a car manufacturing plant follows a fixed path through a completely known layout with predefined obstacle zones. Or else, you can take the example of this. The robots which are used in the hospitals or in the manufacturing industries. That is also a kind of known environment. These are the few characteristics of the new known environment. As all the information, the complete information is known to the robot in advance, definitely a pre-built map will be available with the robot. So that pre-built map means configuration from the physical space, workspace to the configuration space, it would be fixed. It is not going to be changed. Like for example, from a CAD file or a previous exploration. So like this, it will get the complete map used in the structured settings such as factories or warehouses. Structured setting means where the objects are fixed. Like in hospitals, the walls, the path through the corridors, and the location of the bed, all these are fixed. It is not going to be changed. Even the factories also, the chairs, tables, all the machinery equipments, all are fixed at a particular place. So that is called as the structure setting. And third one is efficient planning is possible since the robot does not need to explore. Efficient planning, as everything is known to the robot, it can plan properly without avoiding anything or without colliding with any object. And global path planning algorithms are used for finding the path in a known environment. Robot uses A-star algorithm or Dijkstra's algorithm for high reliability. So these are the characteristics of this known environment. Then the second one is partially known environment. The robot has, when the robot has incomplete information about the environment. That means robot will not have the complete information about the environment. Some areas are mapped while other needs to be explored or updated during the operation. Like a hospital delivery robot. The same hospital robot, the delivery robot, you can take the example for the known environment, even for the partially known. When it is considered as the partial, now you can see the hospital delivery robot knows the general layout of the rooms and corridors, but updates its map when a bed or trolley is blocking a hallway. So suddenly a trolley comes in front of the robot or the bed comes in front of the robot. That happens suddenly. So that is called as the partially known environment. Though the walls and corridors and rooms are fixed, but all these movable objects, it may come at any point of time. In that case, it is called as partially known environment. And these are the few characteristics of the partially known environment. Like dynamic updates to the map are necessary. Mapping will be done, or mapping will be continuously changing in the dynamic environment. It combines the preloaded maps with sensor based updates, as well as is very common in service robots, delivery robots, or any robot operating in semi-structured setting, and it requires local planning and replanning when encountering new obstacles. These are very easy sentences. I hope you can understand. And the third one is the unknown environment. When the robot will does not have any prior information, that is called as unknown environment. The robot has no prior information about the environment and must build the map completely from the scratch while navigating. So whenever the robot explores on the environment, on the spot, it has to find, or it has to map the workspace to the configuration space. So that is the example is the search and rescue robot. These are used to save the life of human being, and it has to explore the path in which, and it has to explore whether that is a it is a victim, or it is a passage, or it is a wall, or it is a human body. It has to find out then only, and it has to explore all the path, all possible paths, so that without colliding with any other obstacles, it has to save the life of human being. So this is the way the search and rescue robot works. So these are the few characteristics of the unknown environment. It uses the real-time sensor data. The robot will use, if the environment is unknown, robot uses the real-time sensor data using radar sensor or cameras or ultrasonic sensors. It is the robot uses both exploration and navigations are performed simultaneously. It has to explore the path as well as it has to navigate the path starting from the starting location to the destination without avoiding the obstacles, and often used in the rescue mission, planetary exploration, and military scenarios, as well as a high computational is in demand for real-time mapping, localization, and planning. So why the high computational means heavy resources are required for performing this task. High computational in the sense, in the form of more processing power is needed, more electricity is needed, more systems are needed, and more space is also required, and more time is also required. So everything is required more compared to other environments where the robot works, especially unknown environment, as a robot has to explore from the scratch to the destination. That is why everything is needed with high computation. So that these are the characteristics of the unknown environment. Now let me discuss about this is very important. If we should know while discussing about the robotics topic, the configuration space. In my previous video already I have discussed. Once again I want to repeat over here. So configuration space represents all possible positions and orientations. All possible positions means if the robot is present in 2D space X and Y axis, if it is present in 3D space X, Y, and Z axis, and its orientation. Orientation means configurations of the robot. How many types of movements are there for the mechanical arm? The robotic, suppose the mechanical arm is having 6 joints, then 6 movements would be there. So each independent movement is called as 1 degree of freedom, 1 DOF. So the number of independent movements by the mechanical arm of the robot, that is called as the number of degree of freedom. So for a robot with n degree of freedoms, the configuration space is equal to, we can represent like this formula. Configuration space is equal to R to the power n, or R to the power n into S to the power n. R to the power n here, it is nothing but the transitional component, and S to the power n is called as the rotational component. Transitional component, either the robot moves in X direction, or it moves in Y direction, or it moves in Z direction. Rotational component, rotation about the Z axis, rotation about Y axis, rotation about X axis. So all the mechanical arms, they can they can perform the transitional movement as well as they can rotate also in its joint. So each particular movement is considered as 1 degree of freedom. So that is why this formula is considered C space is equal to r to the power m, r to the power n. N is nothing but the number of degree of freedoms. If there is no rotational component, then this formula would be r to the power n. If both the transitions are there, like both the degree of freedoms are there, both transitional and rotational, then the formula would be C space is equal to r to the power n into s to the power n. And one more important component here is free space and obstacle space. That is, in configuration space, some spaces are free where the robot can plan to move. That is called as C of free. That is configuration space free. And obstacle space means where the obstacles are occupied. That is represented as C ups. Okay, so these are the important terminologies we need to remember for the configuration space. Now let me discuss about the path planning techniques. There are two different path planning techniques are used by the robot to perform the planning, because as path planning, it is like planning a path starting from the start location to the destination. Orally we can say it will try to explore. But what are the methods are used to explore? So these are the two different techniques. One is the classical method. Second one is the AI and ML based method, artificial intelligence and machine learning based methods. So classical methods, in classical methods, two different algorithms are used. One is the graph based search algorithms and second one is sampling based search algorithm. In graph based algorithm, already we are aware of this, the Dijkstra's algorithm and A-star algorithm. In A-star, one of the function we used to use to find out the cost of a particular node, that is represented as f of n is equal to g of n plus h of n, where g of n is nothing but the distance from the root node to the current node. Suppose this is the current node and this is the root node, this part root node, then this distance is called denoted as gn. Whereas from the current node to the destination, suppose this is the destination node, this is the root node, this is destination node. So from the current node to the destination node, that is called as h of n. So to find out the function or to find out the cost of a particular node, this is the function. So f of n for this particular node can be calculated as g of n plus h of n. So this is the formula we used to use. So using this Dijkstra's algorithm and A-star algorithm, the robot can navigate or robot can plan the path from the starting location to the destination. Even the sampling based algorithms are also used, like probabilistic roadmap and rapidly exploring random tree also for the path exploration. Now the second technique is AI and ML based method. Like in AI and ML, these are the emerging technologies are also used for exploring the path for the robot, like reinforcement learning, deep Q learning and imitation learning. In reinforcement learning, learning optimal policies through interaction, and in deep Q learning, mapping stage to action with neural networks, and imitation learning, learning from the expert demonstrations. So these are the techniques are used for finding the path from the starting location to the destination. I hope you might have understood this the concept, how the path is planned and how the robot navigates in different types of environment, whether it is a known environment or unknown environment or it is a dynamic environment. So for the preparation of this video, I have referred this Russell and Big book, which is visible on the screen. So next class I will discuss about the few application domain of robotics. Till then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.